Today, we're going to be comparing and ordering rational numbers. Before we start, I would like to review a few concepts with you. When you're comparing numbers, we use some of these signs: less than, equals to, and greater than. I know that you might say, wow, they look extremely the same, but they're not the same. As you can see, one is pointing to the right and the other one is pointing to the left. I'm going to give you this tip in case that you tend to get confused. This sign will be always pointing at the small number. The opening of the sign will be facing the big number. For example, I might say 10 is greater than 3. You see? I am pointing at the small number and the opening is facing at the big number. Another example could be 5 is less than, you see, I'm pointing at the 5 that is less than 24. All right? The opening is facing at the 24. Another thing that I would like you to remember is that on a number line, in the right side, we have the positive numbers. In the left side, we have the negative numbers. They behave differently because in the positive side, as they move away from 0, they get bigger and bigger and bigger. They're growing, you see? And in the negative side, as they move away from 0, they get smaller and smaller and smaller. It's like they're shrinking. All right? So it's something very important to remember because if I am comparing a positive number and a negative number and I forget about this behavior, you might get it wrong. Okay? So let's try an example. Let's try to compare 2 and negative 4. Okay? So if I have 2 here and negative 4 here, which one is greater? Yes, 2, positive 2 is greater than negative 4. Okay, this is not positive 4. Okay, so that is something important that you need to remember. In the negative side of the number line, as they move away from 0, they get smaller, smaller, and smaller. The numbers are shrinking. In the positive side, as they move away from 0, the numbers get bigger and bigger and bigger. So that is something very important to remember when you are comparing any rational numbers, okay? So let's try to do the first exercise. In this exercise, we're going to be comparing the absolute value of positive 9 and the absolute value of negative 9. Remember, the absolute value is pretty much the distance of that number and 0 in the number line, okay? If you do not remember, you can even draw the number line and use it as a reference, okay? The absolute value of positive 9 is positive 9, and the absolute value of negative 9 is also positive 9. So now that I found both of the absolute values, I can see that they are the same. They're equal. Absolute value of positive 9 and absolute value of negative 9 is the same. They have the same distance from 0. How about this one? Absolute value of negative 3 and the opposite, that's why this negative sign is outside, the opposite of the absolute value of positive 2. So let's do. Absolute value of negative 3 is positive 3, and then absolute value of 2 is 2, and then you need to bring down this sign that is outside. So your answer will be negative 2. Do you remember what I did here? Yes, these bars are grouping symbol. And according to the order of operations, I need to do the grouping symbol first. That's why I found the absolute value of positive 2 first. Absolute value of positive 2 is positive 2. And then I needed to bring down this sign that is outside. So my final answer will be negative 2. So let's see. I am actually comparing positive 3, okay, which is, remember, absolute value of negative 3 is right here, which is positive 3. And I'm comparing negative 2, which is the opposite of the absolute value of positive 2. As you can see, positive 3, or the absolute value of negative 3, is greater. Yes, is greater. So my sign will be facing towards the greater number, the biggest number, okay? How about you try this one, okay? It's exactly the same process, only that in this case, we're using decimal number. Please pause this video and try it by yourself. Well done. Absolute value of 4.9 is 4.9. Absolute value of negative 5.3 is actually positive 5.3. Okay? If you want to, you can plot these points here in the number line. If not, you can easily see that 5.3 is greater than 4.9. So my sign will be pointing at the smallest number. That in this case is absolute value 4.9. If you cannot see it right away, you can line up the decimal points, 5.3, 4.9, and then you start doing it place value by place value. 5 and 4, well, 5 is greater. So this number is greater than 4.9, okay? There are cases where you need to compare a decimal number by a fraction. What I suggest, if it's a little tricky for you to plot them on a number line or to see it right away, is that you change the fraction into a decimal by dividing numerator by denominator. So if I divide 3 divided by 2, I will get 1.5 as a decimal. So now, the absolute value of 3/2 is actually positive 3/2 or positive 1.5. The absolute value of negative 2.5, it is actually positive 2.5. So now I can clearly see that 2.5, or the absolute value of negative 2.5, is greater than the absolute value of 3/2. Okay? How about this other example? If you want to, you can stay with the fractions, you can keep the fractions, or you can change them into decimal if it's easier for you. In this case, I'm going to compare the opposite of the absolute value of 1/2 by negative 1/4. So, I already know that 1 divided by 2 is 0.5 and 1 divided by 4 is equals to 0.25. So, the absolute value of half, or the absolute value of 0.5, it is positive 0.5. But as this sign is outside the bars, I need to bring it down. So it will be negative 0.5, the opposite of the absolute value of 1/2. In this case, I don't have any bars, but I cannot move this sign. I need to keep this sign, okay? So it will be negative 0.25 because I divided 1 by 4 and I got 0.25. This case, you might say, this is very easy because I can clearly see which one is greater, but it can be tricky because in the negative side, and you see that both numbers are negative, all right? The numbers, as they move away from 0, like -1, -2, and so on, they move away from 0, they get smaller and smaller and smaller. So if I have negative 0.5, which is kind of here, and then negative 0.25, which is here, I can see that negative 0.25 is closer to 0, which means that is greater than. All right? So in this case, negative 1/4 is greater than the opposite of the absolute value of 1/2. So you need to be very careful when both of the numbers are negative. Now that you have a better understanding on how to compare rational numbers, we're going to order them from least, from the very small one, to greatest, from the biggest one. All right? So this is what I do and really help me remembering which number I already use or not. So I draw an arrow under each number. Draw an arrow under each number, okay? So, negative 2.1, it will stay the same, negative 2.1. I need to find the absolute value of 5, which is 5. I need to find the absolute value of 4, which is 4. This one will stay the same, 8. But as I don't have any other fractions, I rather use a decimal form so I can match this with this other decimal, all right? So I am going to divide numerator by denominator, 7 divided by 12, and it is 0.5833. Kind of long, I know. Remember that it's negative, all right? Negative 0.5833. So now I need to think about out of all these numbers, which one is the smallest one? Of course, I am going to focus in the decimal numbers first. So remember, in the negative numbers, okay, the numbers that are moving away from 0 are actually the smallest number of all, because as they move away from 0, they become smaller and smaller and smaller. So as negative 2.1 is farther from 0 than negative 0.58, I am going to use this number as the least one. Yes, this is the least number, the smallest number, negative 2.1. Another thing that I use, so I can remember that I already used this one, is to cross it out. I'm going to cross it out so I can remember that I'm still missing these other 4 numbers, okay? Comma. Now from the numbers that I have available, the second smallest or the smallest number from this set is definitely negative 7/12. In this case, I am going to use the original number, not the conversion that I did here. It will be negative 7/12. I'm going to cross it out so I can remember I already used it. By doing this strategy, I find it very visual for me. So I know that these are the ones that are available. Now, out of 5, 4, and 8, obviously positive 4 is the smallest of these 3. So again, I'm not going to use this number. I'm going to use the original one from the exercise. So it will be absolute value of 4, comma. cross it out. So you can see that you already use that number. Out of absolute value of 5 and positive 8, obviously, absolute value of 5 is smaller. So I'm going to do absolute value of 5 here, and I'm going to cross it out. Now, the greatest number of all this set is positive 8. I cross it out. So now, I just order my rational numbers from least to greatest.